Hello viewers, welcome to the series on convolutional neural network, and in this video we are going to discuss about identifying images and neural network. So let's look at how to train the neural network to recognize images. Before we can use the neural network to make classification, we need to train it. Let's pretend that we are training a simple neural network that can recognize the handwritten number 5. To do this, we need to collect the dataset of training images. We need lots of images that belong to the class that we want to recognize. In this case, we will collect thousands of images of the letter phi written by lots of different people. We also need lots of images that represent the other possible kinds of images that we will see. So that way the neural network can learn to tell the two different types of classes of images apart. So we will also collect thousands of images of the other numbers as part of our training data set. Now that we have been training the data, we can train the neural network by showing it images and telling it what the correct answer will be for each one. So we will start by showing it some 5 and telling it the answer should be 1 to represent true. So here we can see the list of dataset which is showing 5 images, and we are telling it the answer should be 1, signifying that it's a 5. Okay, so we will give lots of different examples of what 5s could look like. As in this case, we will also show it other numbers and tell it that the answer should be 0 to represent false. So on the left hand side we can see the numbers of digits which are not 5, and on the right hand side we can see the expected output as 0, so that we are telling the model that these are the numbers which does not represent 5. So after repeating this process over and over with lots of images, the neural network will eventually learn weights for each node that will make it possible to separate the images of the number 5 from the images of other numbers. Now that the neural network is trained, we can pass in a new image and it will tell us its best guess for the correct answer. This is called prediction. But instead of telling us exactly 0 or 1, it will give us a floating point number in that range depending on how well it can determine the correct class. So if we pass in a 5, it might give us a value close to 1 like 0.95. And if we pass it another number, it might give us a number close to 0 such as 0.05. But being able to only detect one kind of digit isn't that useful, and we could train a separate neural network to recognize each different digit, but that's a lot of work. Instead, we can build a simple neural network that has more than one output. If we give the neural network one output for each possible digit that we will want to detect, it will give us a probability score for each one. This works same way as before, except that we train it by telling it to predict the 1 for the correct answer and 0 for all the other answers. In a modern image recognition model, we often building neural networks that can predict thousands of different classes of objects. It's not usual to have 1,000 or more output nodes in a neural network. When we train the neural network, the different layers of the neural network naturally learn to look for different patterns in the input data. We can roughly think of top layers as looking for simple patterns like lines and sharp edges, and the lower layers use a signal from the higher layers to look for more and more complex shapes and patterns. With all the layers working together, the model can identify very complex objects. That means that adding more layers to the neural network tends to give it a capacity to learn more complex patterns and shapes. This is where the term deep learning originally came from. Deep learning is just the idea that making models deeper by adding more capacity to them so that it can recognize more complex patterns and data. So I hope you have grasped the concept of how the training phase goes on for the image recognition. So I hope you have learned something extra than what you were knowing earlier. Thank you.